what I'm actually going to start is the new component called Hive. Okay, so let's understand what is Apache Hive all about. So till last session, what we saw is the SDFS framework. Okay, the or SDFS component, which is meant for uh, storing your data across multiple machines in your Hadoop cluster, and also we saw how to process those data which is stored across machine using a programming model called MapReduce. Okay. Now, uh, so example, you have a team uh, which has which has a database developer in your team, and they find um, difficult to write a MapReduce job and um, execute on the cluster. And also if you have a structured data, right, so you don't, I mean, see, you also have to process your structured data and analyze your data to get a insight out of it. There comes the usage of Apache Hive, right? So if your data set is structured data, and then if you want to process that, then we will be using Apache Hive because it provides you SQL interface. Okay, so where you can go and create a table. You can actually represent your data in a table format, and then you can write queries, the SQL compatibility queries, and you can process it. So here we use query language called IQL, Hive query language. So if you just go through the definition about Apache Hive, so Apache Hive uh, um, data warehouse software facilitate reading and writing and managing large data set residing in a distributed storage using a SQL interface. And structure can be projected into data already in the storage. Okay, so whatever the file you have it in your STFS, you are going to provide a structure. There are common tool and JDBC drivers to provide it to connect users to the Hive. So you have command type. You can actually connect to the Hive using a command line tool, or you can use the JDBC driver. Makes a MapReduce easy because what it is going to do is behind the scene, it is going to convert your Hive QL queries into uh, uh, MapReduce job in terms of map and reduce task, right? So whatever you write the Hive, it is going to convert them into MapReduce jobs. Okay, easy to implement joins and optimize executions. Okay, so it supports concepts like partitioning and buckets. Okay, so we'll go in detail when you so basically when you go into those topics, basically you want to organize your data into multiple smaller segment and process on top of it. Then support multiple file formats, and this is going to be a schema on read. So which means basically you get a table and you keep when you read it data from HDFS, you're going to create a schema and then try to use the schema and process your data. Okay, and if you want to just compare with the normal RDBMS with the Hive, so basically Hive is not a database, right? It is just a SQL interface. Okay, so RDBMS is a database management system. In that you will use SQL interface, right? It supports the SQL structure query language as a um, interface. Here also, it's SQL interface is used. Something the SQL interface called HQL. Okay, now focus on analytics and big data analytics. Basically, it supports OLAP and batch processing. And in RDBMS, we support OLTP and OLAP. OLTP means online transaction processing. OLAP means online analytical processing. Okay, OLAP mostly all the data warehouse softwares, basically OLAP. And limited transaction supports. And here we have all the transaction supports, all your um, asset properties and commit and um, commit and roll back other stuff. So delete and update all the stuffs. Here, the delete and update was initially not supported. Then later point with some limitation, it is supported here. And distributed processing via MapReduce. Here there is no distributed processing, but there are some RDBM system supports with limited features. Okay, it can scale up to hundreds of nodes. It is limited for scaling the nodes. This can be built on the IU can be built on the commodity hardware. This is often built on proprietary or specialized hardwares. Okay. Uh, Limited indexing support. It has full indexing support. No triggers supported in Apache Hive. So in RDBMS we have something called trigger, which is basically set of logic will be triggered whenever you perform operation on your RDBMS tables. So that was basically the quick difference between Apache Hive and RDBMS systems. So if you want to conceptually uh, understand, so basically there will be a component called metastore, Hive metastore, okay, which is going to hold your table information, right? What you are going to do is you will have a file. Like example, my file is a represent a structured data. Say example, it is as a user information, right? User ID and name and age and city. So which is was say example stored as a CSV file or JSON file, right? I can create a table for that file. Okay, so I can create table user, okay, and then point it to this table, or I can create a table and use load command to load or insert command to load the data into the user table, right? So when you create a table, the table information is stored on metastore, the component called metastore, and then it will be um, available for you to query the tables, okay, which internally converts MapReduce job and process on the data which is sitting on HDFS. This is uh, uh, the conceptual view of Hive tables. Okay, so before going to, there are two types of table in Hive. Okay, before going to this, uh, I will go to Hive architecture. Just a minute. Okay, so basically, if you look at the architecture of Hive, okay, so this is going to be a Hive architecture. So you will have a Hive driver, okay, which is the basically the point of contact for Hive, right? Like this is the you can call this as a Hive course service called driver, okay. So you can connect to this Hive's driver or Hive service via different interfaces. One is Hive server, another Hive CLI, so you have command line interface and you have web interface, okay. So if you want to connect so if you want to connect Hive CLI, you can just let me start my VM. You can open a terminal, okay. um, you can open a terminal and type Hive. So then the command line interface, Hive command line interface will start, okay. And once it is started, you can write some queries to, you can start creating a tables and query your data, okay. That is one way to interact with your Hive driver. So other way is, example, programmatically, if you want to connect, say example, you have a system and which from there you want to run a Hive statement. It can be a any query or create table. You can use a Hive server, okay. So how you can connect this through Hive Thrift client or Hive JDBC or Hive ODBC driver. Using that, you can actually use it in your application. So if you are using any Java based application, from that you can actually use Java JDBC, Hive JDBC driver, and you can pass a query which will be taken by the Hive server and given to the driver. The driver which will go and refer the metastore for the table information. If you are creating, it will go and create the table and store the metadata information here, and then it will actually launch MapReduce job, okay, and run the MapReduce job. So using a file system and file system is to read your HDFS data, and job client to submit your MapReduce job on the cluster. And this is how the Hive architecture works. If you go in detail about the driver, how the driver process works, um, I will give this one. So basically, so when the query comes to the uh, uh, the Hive driver, so basically it will actually compile. Okay, that it will send to the compiler, which it take the semantics and syntax of your Hive, whether it is all the things are correct. So when the compiler says okay, and then it will be sent to the optimizer. Okay, just to optimize your query. Okay, once it is get us sign off from its optimizer, then it will go send. There is a one more component called execution, okay, and which will actually create the DAGs. Okay, the DAG is basically a job, the MapReduce job in terms of map and reduce task, and it will go and reduce. Sorry, it will go and run on the uh, MapReduce on top of your yarn if you are using Hadoop 2 version. Anyway, for the metadata information about table, it will go and refer the metastore. Uh, do you have any question on this?
Pari, I have a small question.
Yeah, tell me.
Yeah, so basically for storage, we use HDFS,
Yeah.
and for processing it, we use MapReduce, right? So what made Hive to come in picture or PySpark when we have already HDFS for storage and MapReduce for processing? So
Okay.
why again Hive and PySpark these came into picture? Like there are any limitations for MapReduce with it?
Yeah, so okay, one is there are a couple of reasons why we use Hive. Okay, we'll come to Spark. I'll come to PySpark later. Okay, so first we'll take what is the need of Hive. Okay, say example, um, you have a file, right? Uh, so you store the file into HDFS. Okay, and if you want to process and you write a MapReduce job. Okay, say example, for first thing is um, if you have a database programmer in your team, okay, uh, or two things. One is if you have uh, a database developer and if you want to make him to write a MapReduce job, it is difficult for him. There will be a learning curve. It's not that he will not write, he will have a learning curve. So he has to learn the programming either Python or Java to write a MapReduce job. That is one part. So just to make him more productivity, we can actually use a Hive like component so that you can just see the data and then you can create a structure for the table and you can start whatever the analysis you can do and uh, to get a output which you can write in MapReduce job. The same thing can be done using a Hive queries so that you can make use of that resource and as well as the productivity to improve the productivity. That is one aspect. Other aspects is okay. So if you have already a switch, when you have a structured data, right? When you have structured data, why don't you why are you want to process using MapReduce, which will give you which will give you data as a key value pair. You have to do a lot of computation or lot of coding to uh, bring your key value pair data into a lot of computation you need to do. Say example, you have a table with 100 columns, right? Or maybe your structured data has 100 fields. Then you have to go and split 100 fields in your MapReduce program. You need to write a lot of coding. So rather, if you have a structured data which has even n number of fields, you can represent them as a tables. Okay, that's what we do in RDBMS. Right. Only thing is we cannot do in RDBMS. We cannot do distributed computing there. Okay. So we just make use of the HQL query language. Okay, and we can represent our data set if it is structured. We can represent data set as a table, and we can query and we can make the processing whatever we can do. And one more thing is, say example, you have a data set and if you want to analyze and if you want to analyze that and if you want to see the set of rows or set of the records from your table or maybe the file, right? You cannot do it in means you cannot do it means uh, you cannot write a ad hoc query. Say example, I just query few records or few records from the structured data which I stored in SDFS. If I want to query in using MapReduce, I cannot just I have to write a MapReduce and generate this set of rows and then store it in another location. Then only I can view it. I cannot just because MapReduce being a sequential, it will read only the data in sequential manner, and you cannot while running the MapReduce job or uh, while running MapReduce job, you cannot see the data, and but also after running, also it will go and store into their STFS directory, and you have to go and view it. But in terms of Hive, you can just write a Hadoop query. Say example, I have a records file with a record of 1,000 rows. I can go and fetch only some 5 rows to just check how the data looks, so that I can in a query I can just put a limit or write a range query to select few records from the Hive table, and then I can view it in a console. Then I can decide my um, I can design a query which does whatever the operation I want to perform. So this is the other aspects. One is okay to make a productivity of your resource. And I say resource basically your team members who have a database knowledge. You can make use of them. And other aspects is if you have a structured data and if you want to do ad hoc queries, then the Apache Hive component is used rather than MapReduce. So is your first question is you're okay or this is the main use of Apache Hive. Are you fine with the answer or or you're hello? Uh, um, are you fine? Varun or Pradap who asked the question? Are you can you hear me? Hello, can you hear me? Am I audible? Hello.
Yes, sir, you are audible.
Okay, so Arun, did you ask question or Pratap asked the question? Arun Raj, sir.
I think Pratap has asked this question. Sorry.
Uh, Pratap, are you fine with the answer? Why we need a Hive?
Yeah, Parth. Yeah.
Okay, so that is with respect to why use Hive. When it when it comes to PySpark, okay, so PySpark is a different scenario. Like why we are going to uh, focus towards the Spark is either Spark with Scala or PySpark, which is Spark with Python API. Uh, if you want to that Hadoop is mainly meant for batch processing. When I say batch processing, so you may run a reports, you may run a set of queries or MapReduce job to generate a reports which will be used for next day. Okay, you take historical data and or maybe 1 or 2 days data and you perform the long complex queries and you schedule it in a nightly job which can generate a report for you tomorrow. Okay, and generally these jobs write in the run in the nights and generate reports. These are generally called as batch processing. And there are need for real-time processing where you as soon as the data comes you need to process and then generate a aggregate or insight out of it. Okay, please use the same link whenever this disconnects. Okay. Uh, generate insights out of it immediately. So there comes the usage of or need of stream processing or real-time processing. So that was not supported in Hadoop. Okay. So that is supported in Spark structure streaming or Spark traditional streaming. That is one aspect. Even if you write a batch queries in Spark, it is going to give you 10 times faster than the Hadoop jobs. Why? Because it's going to do the in-memory processing. When I say in-memory processing, they are going to make use of uh, uh, the RAM or the uh, memory, okay, to process your data. So what is going to do is it is going to use the memory resource from across your cluster to load your data into memory and process it. So in a way, it is because the MapReduce does a sequential processing, right? So it will, even though the blocks will be running on parallel to improve the performance, still if you look at the individual map task execution, it is a sequential processing, means disk based processing. It will go and read each line for a respective block, and it takes the data into memory and process. That's how individual map task execution on particular machine. Of course, it will does the parallel processing, means all your blocks for a respective file is processed in parallel. That is one good aspects. But when you compare to PySpark, all these blocks will be loaded into memory, and it will process even faster, 10 times faster than the MapReduce. So that is one aspects why you use PySpark. The other aspects is it supports real-time or stream processing as well. So these are the two main you know, things which will be using for PySpark. These are two main important points to use a PySpark. Okay, so coming back to the Hive architecture, um, so these are the driver is the main process which takes your query and does compiling, optimizing, and it will use the execution. There is one more component called executor or execution, which sends your the optimized query into the convert it as a DAG and run a MapReduce framework. Okay, and then it will give you a result. So it can be shown on your CLI. So B line is the one of the command line interface for Hive. So when initially when Hive came with it came with a command line interface. So Hive is generally, if you type Hive, it will go and open a command line interface. This is the default command line interface. There is a other okay. I have to start my, so to work Hive to work, you need to start your SDFS and MapReduce services, which is yarn services. Let's say start data search, and also open one more session. This is my installation location of Hive, and you can see basically what we use Hive CLI, which I going to launch here. Which is a command line interface, and also there is a beeline utility, which is also similar like ICLI. Okay, so recent version you see beeline, and nowadays people suggest to use beeline. Okay, so so this is ICLI. I can just go and type a command called show databases. So in Hive we represent table inside, we keep a database and we create a table inside database like how you do on RDBMS. Okay, but internally the processing or things are different here. Okay? But the way we organize tables is basically inside the database. That's what we do in normal RDBMS also. The table is created inside the database. Okay. Do you have any question on Hive architecture?
So Pari, Hive is good for structured data, or
Yes.
even for unstructured also we can do it.
Yeah. So basically, you can. There are basically mainly for structured data, unstructured
Okay.
data, JSON or CSV. Um, then the XML, I don't know whether it has sort of libraries. But yeah, JSON it is there. They call it as SERD, okay, deserializer and serializer. There are set of libraries available. It is also good for semi-structured data, but there is a few things are out of box available, and a few things we need to use third-party libraries.
Oh, okay, Pari. Yeah.
Yeah. Okay, now coming back to there is a tables. We saw about how the table is basically it can be visualized as a how the table is used in Hive. So when you create a table, the table metadata will be stored on metastore. So this metastore is basically another database system. Okay, so by default it uses the embedded memory database called Derby. Okay, so to store your table metadata, but you can actually when you go to production, you will be configured this iMetastore as like MySQL or Postgres or any other database system. So I give you steps where you can configure this iMetastore as a MySQL to install Hive. Okay, so we'll have a file in HDFS and you represent file data as a table in Hive, and then we start querying it. Okay. Okay, so we have two types of table in Hive. Okay, managed table or internal tables, and the other type of table is the external table, right? Okay, so we'll just I'll disconnect this session. Please use the same link and join because we have only 1 minute left. Uh, I don't want to just break this video in between. Okay. Just please use the same link and join.